A meteoroid is a small rocky or metallic body traveling through space. Meteoroids are significantly smaller than asteroids, and range in size from small grains to 1 meter wide objects. Smaller objects than this are classified as micrometeoroids or space dust. Most are fragments from comets or asteroids, while others are collision impact debris ejected from bodies such as the Moon or Mars. When such an object enters the Earth's atmosphere at a speed typically in excess of 20 km per second, aerodynamic heating produces a streak of light, both from the glowing object and the trail of glowing particles that it leaves in its wake. This phenomenon is called a meteor, or colloquially a shooting star, or falling star. A series of many meteors appearing seconds or minutes apart, and appearing to originate from the same fixed point in the sky, is called a meteor shower. Incoming objects larger than several meters can explode in the air. If a meteoroid, comet or asteroid or a piece thereof withstands ablation from its atmospheric entry and impacts with the ground, then it is called a meteorite. Around 15,000 tons of meteoroids, micrometeoroids and different forms of space dust enter Earth's atmosphere each year. Meteoroids. In 1961, the International Astronomical Union defined a meteoroid as a solid object moving in interplanetary space, of a size considerably smaller than an asteroid and considerably larger than an atom. In 1995, Beach and Steele, writing in Quarterly Journal of the Royal Astronomical Society, proposed a new definition where a meteoroid would be between 100 micrometer and 10 meters across. Following the discovery of asteroids below 10 m in size, Rubin and Grossman refined the Beach and Steele definition of meteoroid to objects between 10 AA micrometer and 1 m in diameter. According to Rubin and Grossman, the minimum size of an asteroid is given by what can be discovered from Earth-bound telescopes, so the distinction between meteoroid and asteroid is fuzzy and dependent of technology. The smallest asteroid ever discovered is 2008 TS-26 with an absolute magnitude of 33.2, and an estimated size of 1 meter. Objects smaller than meteoroids are classified as micrometeoroids and cosmic dust. The Minor Planet Center does not use the term meteoroid. Meteoroid composition: almost all meteoroids contain extraterrestrial nickel and ions. They have three main classifications: ions, stones and stony ions. Some stone meteoroids contain grain-like inclusions known as chondrules, and are called chondrites. Stony meteoroids without these features are called chondrites, which are typically formed from extraterrestrial igneous activity. They contain little or no extraterrestrial iron. The composition of meteoroids can be inferred as they pass through the Earth's atmosphere from their trajectories and the light spectra of the resulting meteor. Their effects on radio signals also give information, especially useful for daytime meteors which are otherwise very difficult to observe. From these trajectory measurements, meteoroids have been found to have many different orbits, some clustering in streams often associated with a parent comet, others apparently sporadic. Debris from meteoroid streams may eventually be scattered into other orbits. The light spectra, combined with trajectory and light curve measurements, have yielded various compositions and densities, ranging from fragile snowball-like objects with density about a quarter that of ice, to nickel-iron-rich dense rocks. The study of meteorites also gives insights into the composition of non-ephemeral meteoroids. Meteoroids in the Solar System: meteoroids travel around the Sun in a variety of orbits and at various velocities. The fastest ones move at about 42 km per second through space in the vicinity of Earth's orbit. The Earth travels at about 29.6 km per second. Thus, when meteoroids meet Earth's atmosphere head-on, the combined speed may reach about 71 km per second. Meteoroids moving through Earth's orbital space average about 20 km per second. On January 17, 2013 at 5:21 Pacific Standard Time, a 1-meter-sized comet from the Oort cloud entered Earth atmosphere. The object had a retrograde orbit with perihelion at 0.98 AA plus or minus a 0.03 AU. It approached from the direction of the constellation Virgo, and collided head-on with Earth's atmosphere at 72 AA plus or minus A6 a kilometer per second, vaporizing more than 100 km above ground over a period of several seconds. Meteoroid collisions with Earth and its atmosphere. When meteoroids intersect with the Earth's atmosphere at night, they are likely to become visible as meteors. If meteoroids survive the entry through the atmosphere and reach the Earth's surface, they are called meteorites. Meteorites are transformed in structure and chemistry by the heat of entry and force of impact. A noted meteoroid, 2008 TC3, was observed in space on a collision course with Earth on 6 October 2008 and entered the Earth's atmosphere the next day, striking a remote area of northern Sudan. It was the first time that a meteoroid had been observed in space and tracked prior to impacting Earth. Meteor, meteor, and meteors redirect here. For other uses, see meteor. A meteor or shooting star is the visible streak of light from a meteoroid or micrometeoroid, heated and glowing from entering the Earth's atmosphere, as it sheds glowing material in its wake. Meteors typically occur in the mesosphere at altitudes between 76 to 100 km. The root word meteor comes from the Greek meteoros, meaning suspended in the air. Millions of meteors occur in the Earth's atmosphere daily. Most meteoroids that cause meteors are about the size of a pebble. Meteors may occur in showers, which arise when the Earth passes through a stream of debris left by a comet, or as random, or sporadic meteors, not associated with a specific stream of space debris. A number of specific meteors have been observed, largely by members of the public and largely by accident, but with enough detail that orbits of the meteoroids producing the meteors have been calculated. All of the orbits pass through the asteroid belt. The atmospheric velocities of meteors result from the movement of Earth around the Sun at about 30 km per second, the orbital speeds of meteoroids, and the gravity well of Earth. Meteors become visible between about 75 to 120 km above the Earth. They usually disintegrate at altitudes of 50 to 95 km. Meteors have roughly a 50% chance of a daylight collision with the Earth. Most meteors are, however, observed at night, when darkness allows fainter objects to be recognized. For bodies with a size scale larger than meteor, visibility is due to the atmospheric ram pressure that heats the meteoroid so that it glows and creates a shining trail of gases and melted meteoroid particles. The gases include vaporized meteoroid material and atmospheric gases that heat up when the meteoroid passes through the atmosphere. Most meteors glow for about a second. A relatively small percentage of meteoroids hit the Earth's atmosphere and then pass out again. These are termed Earth-grazing fireballs. The visible light produced by a meteor may take on various hues, depending on the chemical composition of the meteoroid, and the speed of its movement through the atmosphere. As layers of the meteoroid abrade and ionize, the color of the light emitted may change according to the layering of minerals. Colors of meteors depend on the relative influence of the metallic content of the meteoroid versus the superheated air plasma, which its passage engenders: orange-yellow, yellow, blue-green, violet, red, fireball. A fireball is a brighter than usual meteor. The International Astronomical Union defines a fireball as a meteor brighter than any of the planets. The International Meteor Organization has a more rigid definition. It defines a fireball as a meteor that would have a magnitude of a 3 or brighter if seen at zenith. This definition corrects for the greater distance between an observer and a meteor near the horizon. For example, a meteor of magnitude 1 at 5 degrees above the horizon would be classified as a fireball because if the observer had been directly below the meteor it would have appeared as magnitude 6. For 2013 there were 3556 fireballs recorded at the American Meteor Society. There are probably more than 500,000 fireballs a year, but most will go unnoticed because most will occur over the ocean and half will occur during daytime. Fireballs reaching magnitude 14 or brighter are called bolides. The IAU has no official definition of bolide, and generally considers the terms synonymous with fireball. Astronomers often use bolide to identify an exceptionally bright fireball, particularly one that explodes. It may also be used to mean a fireball which creates audible sounds. In the late 20th century, bolide has also come to mean any object that hits the Earth and explodes, with no regard to its composition. The word bolide comes from the Greek I², which can mean a missile or to flash. If the magnitude of a bolide reaches a 17 or brighter, it is known as a superbolide. Atmospheric remains of meteor passage. Entry of meteoroids into the Earth's atmosphere produces three main effects: ionization of atmospheric molecules, dust that the meteoroid sheds, and the sound of passage. During the entry of a meteoroid or asteroid into the upper atmosphere, an ionization trail is created, where the molecules in the upper atmosphere are ionized by the passage of the meteor. Such ionization trails can last up to 45 minutes at a time. Small, sound grain-sized meteoroids are entering the atmosphere constantly, essentially every few seconds in any given region of the atmosphere, and thus ionization trails can be found in the upper atmosphere more or less continuously. When radio waves are bounced off these trails, it is called meteor burst communications. Meteor radars can measure atmospheric density and winds by measuring the decay rate and Doppler shift of a meteor trail. Most meteoroids burn up when they enter the atmosphere. The leftover debris is called meteoric dust or just meteor dust. Meteor dust particles can persist in the atmosphere for up to several months. These particles might affect climate, both by scattering electromagnetic radiation and by catalyzing chemical reactions in the upper atmosphere. Larger meteors can enter dark flight after deceleration, where the meteorite fall at terminal velocity. Dark flight starts when the meteorite decelerate to about 2 km per second. Larger fragments will fall further down the strewn field. Sounds of meteors, sound generated by a meteor in the upper atmosphere, such as a sonic boom, typically arrives many seconds after the visual light from a meteor disappears. Occasionally, as with the Leonid meteor shower of 2001, crackling, swishing, or hissing sounds have been reported, occurring at the same instant as a meteor flare. Similar sounds have also been reported during intense displays of Earth's auroras. Sound recordings made under controlled conditions in Mongolia in 1998 support the contention that the sounds are real. Theories on the generation of these sounds may partially explain them. For example, scientists at NASA suggested that the turbulent ionized wake of a meteor interacts with the Earth's magnetic field, generating pulses of radio waves. As the trail dissipates, megawatts of electromagnetic energy could be released, with a peak in the power spectrum at audio frequencies. Physical vibrations induced by the electromagnetic impulses would then be heard if they are powerful enough to make grasses, plants, eyeglass frames, and other conductive materials vibrate. This proposed mechanism, although proven to be plausible by laboratory work, remains unsupported by corresponding measurements in the field. Seasonal variation in meteor sightings. A meteor shower is the result of an interaction between a planet, such as Earth, and streams of debris from a comet or other source. The passage of the Earth through cosmic debris from comets and other sources is a recurring event in many cases. Comets can produce debris by water vapor drag, as demonstrated by Fred Whipple in 1951, and by breakup. Each time a comet swings by the Sun in its orbit, some of its ice vaporizes and a certain amount of meteoroids will be shed. The meteoroids spread out along the entire orbit of the comet to form a meteoroid stream, also known as a dust trail. The frequency of fireball sightings increases by about 10 to 30% during the weeks of vernal equinox. Even meteorite falls are more common during the northern hemisphere's spring season. Although this phenomenon has been known for quite some time, the reason behind the anomaly is not fully understood by scientists. Some researchers attribute this to an intrinsic variation in the meteoroid population along Earth's orbit, with a peak in big fireball-producing debris around spring and early summer. Research is in progress for mapping the orbits of the meteors to gain a better understanding of the phenomenon. History. Although meteors have been known since ancient times, they were not known to be an astronomical phenomenon until early in the 19th century. Prior to that, they were seen in the West as an atmospheric phenomenon, like lightning, and were not connected with strange stories of rocks falling from the sky. Thomas Jefferson wrote, "I would more easily believe that Yankee professor would lie than that stones would fall from heaven." He was referring to Yale chemistry professor Benjamin Silliman's investigation of an 1807 meteorite that fell in Weston, Connecticut. Silliman believed the meteor had a cosmic origin, but meteors did not attract much attention from astronomers until the spectacular meteor storm of November 1833. People all across the eastern United States saw thousands of meteors, radiating from a single point in the sky. Astute observers noticed that the radiant, as the point is now called, moved with the stars, staying in the constellation Leo. The astronomer Denison Olmsted made an extensive study of this storm, and concluded it had a cosmic origin. After reviewing historical records, Heinrich Wilhelm Matthias Olbers predicted the storm's return in 1867, which drew the attention of other astronomers to the phenomenon. Hubert A. Newton's more thorough historical work led to a refined prediction of 1866, which proved to be correct. With Giovanni Schiaparelli's success in connecting the Leonids with comet Tempel-Tultul, the cosmic origin of meteors was now firmly established. Still, they remain an atmospheric phenomenon, and retain their name meteor from the Greek word for atmospheric. Notable meteors. 1992 Peekskill, New York. The Peekskill meteorite was filmed on October 9, 1992 by at least 16 independent videographers. Eyewitness accounts indicate the fireball entry of the Peekskill meteorite started over West Virginia at 23:48 UT. The fireball, which traveled in a northeasterly direction, had a pronounced greenish color, and attained an estimated peak visual magnitude of 13. During a luminous flight time that exceeded 40 seconds, the fireball covered a ground path of some 700 to 800 km. One meteorite recovered at Peekskill, New York, for which the event and object gained their name, had a mass of 12.4 kg and was subsequently identified as an H6 monomicted Brixia meteorite. The video record suggests that the Peekskill meteorite had several companions over a wide area. The companions are unlikely to be recovered in the hilly, wooded terrain in the vicinity of Peekskill. 2009 Bone, Indonesia. A large fireball was observed in the skies near Bone, Indonesia on October 8, 2009. This was thought to be caused by an asteroid approximately 10 meters in diameter. The fireball contained an estimated energy of 50 kilotons of TNT, or about twice the Nagasaki atomic bomb. No injuries were reported. 2009 Southwestern U.S., a large bolide was reported on November 18, 2009 over southeastern California, northern Arizona, Utah, Wyoming, Idaho and Colorado. At 007 local time, a security camera at the high-altitude W.L. Eccles Observatory recorded a movie of the passage of the object to the north. Of particular note in this video is the spherical ghost image slightly trailing the main object, and the bright fireball explosion associated with the breakup of a substantial fraction of the object. An object trail can be seen to continue northward after the bright fireball event. The shock from the final breakup triggered 7 seismological stations in northern Utah. A timing fit to the seismic data yielded a terminal location of the object at 40.286 N, minus 113.191 W, altitude 27 km. This is above the Dugway Proving Grounds, a closed Army testing base. 2013 Chelyabinsk Oblast, Russia. Over 1,500 people were injured, mostly by glass from shattered windows caused by a meteoroid explosion during meteor event in Chelyabinsk Oblast, Russia on February 15, 2013, when a meteoroid exploded approximately 25 to 30 km above the environs of Chelyabinsk, Russia. An increasingly bright streak was observed during morning daylight with a large contrail lingering behind. At no less than 1 minute and up to at least 3 minutes after the object peaked in intensity, a large concussive blast was heard that shattered windows and set off car alarms, which was followed by a number of smaller explosions. Scientists at NASA's Jet Propulsion Laboratory estimated the meteoroid to have an initial mass of 11,000 tons, and to measure approximately 17 to 20 meters across, as it entered the Earth's atmosphere. Gallery of Meteors. Meteorite and meteoroid impacts. A meteorite is a portion of a meteoroid or asteroid that survives its passage through the atmosphere and hits the ground without being destroyed. Meteorites are sometimes, but not always, found in association with hypervelocity impact craters. During energetic collisions, the entire impactor may be vaporized, leaving no meteorites. Geologists use the term bolide in a different sense from astronomers to indicate a very large impactor. For example, the USGS uses the term to mean a generic large crater-forming projectile in a manner to imply that we do not know the precise nature of the impacting body. Whether it is a rocky or metallic asteroid, or an icy comet for example. Meteoroids also hit other bodies in the solar system. On such stony bodies as the Moon or Mars with no or little atmosphere, they leave enduring craters. Frequency of large meteoroid collisions with Earth. The diameter of the biggest impactor to hit Earth on any given day is likely to be about 40 centimeters in a given year, about 4 meters, and in a given century about 20 meters. These statistics are obtained by the following: over at least the range from 5 centimeters to roughly 300 meters. The rate at which Earth receives meteors obeys a power law distribution as follows, where n is the expected number of objects larger than a diameter of d meters to hit Earth in a year. This is based on observations of bright meteors seen from the ground and space, combined with surveys of near-Earth asteroids. Above 300 meters in diameter, the predicted rate is somewhat higher, with a 2-kilometer asteroid every couple of million years, about 10 times as often as the power law extrapolation would predict. Meteorite and meteoroid impact craters. Meteoroid collisions with solid solar system objects, including the Moon, Mercury, Callisto, Ganymede and most small moons and asteroids, create impact craters, which are the dominant geographic features of many of those objects. On other planets and moons with active surface geological processes, such as Earth, Venus, Mars, Europa, Io and Titan, visible impact craters may become eroded, buried or transformed by tectonics over time. In early literature, before the significance of impact cratering was widely recognized, the terms cryptoexplosion or cryptovolcanic structure were often used to describe what are now recognized as impact-related features on Earth. Molten terrestrial material ejected from a meteorite impact crater can cool and solidify into an object known as a tektite. These are often mistaken for meteorites. Gallery of meteorites. See also, relating to meteoroids, interplanetary dust, micrometeoroid, near-Earth object, relating to meteors, North American Meteor Network, American Meteor Society, green fireballs, hydrometeor, International Meteor Organization, Leonids, list of meteor airbursts, list of meteor showers, Lyrids, Orionids, Perseids, Tolman's hypothetical bolide, relating to meteorites, Vertilis are sacred stones made from meteorites, impact crater, impact event, meteorite, micrometeorite, stratospheric micrometeorites, tektite, references. External links. A History of Meteors and Other Atmospheric Phenomena, American Meteor Society, British Astronomical Society Meteor page, International Meteor Organization, Live Meteor Screen, Meteoroids page at NASA's Solar System Exploration, Meteor Shower Predictions, Meteor Showers and Viewing Tips, Society for Popular Astronomy, Meteor section.